One benefit of these template transformations is that we can use them to interpolate VSecM secrets into Kubernetes secret objects. This is typically not recommended, as there are better ways for workloads to consume VSecM secrets, such as using VSecM SDK or VSecM Sidecar. But for legacy use cases where you need to consume a Kubernetes secret, or for apps that you don't have control over their source code, secret interpolation will be helpful. As always, if you find value in what you learned today, please give us a star on GitHub at github.com/VMware Manager. Your support helps others discover this incredible technology. Here is how secret interpolation works. You specify your template transformation as usual, but this time use a -K flag to indicate that you wish to update a Kubernetes secret too. Your secret is registered to VSecM Safe, and VSecM Safe updates the Kubernetes secret, adding the transformed values into the Kubernetes secret. Your workload has an init container polling VSecM Safe for registered secrets. When the init container finds a secret is registered, it lets the main container initialize, and the main container will consume the generated Kubernetes secret as it pleases, either mounted as a volume or mapped as environment variables. Now, let's see all of this in action. I'll save the script to my server again. Then, I'll delete the secret for the workload and view the secret to make sure that the secret is indeed deleted. If I try to register the Kubernetes secret directly, I'll get an error that the VSecM secret example secret is not found. As a security measure, VSecM will not create the secret if it does not exist. So we'll have to create an empty secret first. Let's do that. I'll create a secrets folder, then cd into it. Then, add this opaque secret YAML here. Please note that the secret is empty. It has no data. Later, VSecM will populate it once we rerun the Kubernetes secret registration command. First, kubectl apply -f, then register secret, and when we get the secret, you can see it is no longer empty. Let's describe it. Kubectl describe secret VSecM secret example, and we have the username, password, and value as expected. And if we filter out the password's value, we can see that it's super secret as expected. To test the init container use case, I'll delete the inspector deployment first. Then, inside this folder, I'll define an example workload deployment manifest that uses an init container. I also want to delete the secret linked to the example workload. Delete secret.sh, and we get an OK. Then I'll copy this init container example from this examples / using init container /cates folder. Copy the deployment manifest first. Create a deployment YAML and paste the text we copied here. We have a container with several secret values bound to the container as environment variables. We also have a VSecM init container that will wait for a secret to be assigned to this workload before it lets the main container begin its life cycle, and the rest is typical VSecM environment variables. By the way, these environment variables all have default values. So if you omit them, VSecM components will assume sensible default values, and your application will likely work without problem. However, we are providing these values to be more explicit. They double as inline documentation too. We'll need a service account for our workload. Let's define that too. Typical service account definition, nothing fancy. Now, let's apply our changes. Kubectl apply -f. Our deployment and service account are created, and when we do a kubectl get po, you'll see that our pod is waiting. Let's check the secret. Well, it's here, so why is the pod waiting? Isn't the init container supposed to let the main container start once a secret is defined for this workload? There's definitely a problem. Let's try to debug it. For starters, just to be on the safe side, I'll delete the VSecM secret example Kubernetes secret. Create a blank secret by kubectl apply-f dot. And then get the Kubernetes secret. And now it is empty. So, if I run the register Kate's secret script, in theory, the init container should detect the newly registered VSecM secret and initialize the pod. Let's run this and cross our fingers. Well, the pod is still pending, but our Kubernetes secret is populated, which also means a VSecM secret is created on VSecM safe, which, in turn, means the init container should detect it and let the main container start, but it doesn't. So, what could be the problem? Well, the issue is, our example workload does not have an SVID assigned to it. For it to get an SVID, we need to define a cluster SPIFFE ID first. The init container cannot establish an MTLS connection with VSecM safe without an ID. Therefore, it cannot know that the workload has an associated secret and, therefore, cannot let the main container start its life cycle. So, let's define an ID for our workload to communicate with VSecM safe. But to verify our theory, I'll deploy the inspector workload we deleted a while ago and check that we have the secret registered to the example workload. cd inspector kubectl apply-f, and when I run view secret, I can see the secret registered to the workload. Having an inspector workload similar to this can be helpful when debugging your apps. The inspector and the example workloads have the same name, example, in their SPIFFE IDs. Therefore, they can receive the same secret. So, in this case, we are sure that the example workload has a secret. The issue is not related to VSecM, but is likely associated with the example workload. And it has to be the missing cluster SPIFFE ID for the example workload. Now that we are almost sure, let's define the cluster SPIFFE ID, cd-IDs, vim-example.yaml to define cluster SPIFFE ID for the example workload. This is the cluster SPIFFE ID. If the workload is in the default namespace with the example service account and has this label, give it this SPIFFE ID. Let's save it, then apply it by kubectl apply-f example.yaml. The workload can take a while to query VSecM safe, because the init container uses an exponential backoff algorithm and checks VSecM safe less frequently if the communication fails. But it will eventually catch up and initialize the pod, and it did, as you see here. When we check the logs of the example pod, you can see that it interpolates the environment variables mapped from the Kubernetes secret that VSecM safe has populated. And that's the end of this demo session. Until the next one, keep your secrets secret.